Now this is the notes, and you're gonna have homework like similar question. But the other question is about goldfish. No, the real fish, not the goldfish. Okay, you go ahead and read for 5 minutes and digest what's gonna happen. So I will explain to you what things are gonna be on AP exam. On AP exam, you're gonna have for sure one question of FTC. The second question that you for sure gonna show is the motion. So we cover FTC, we cover motion. The third thing a lot of time it will show is called net rate. This is the third one. So by those three questions, guess what? You will have 27 points. Again, you only need a 42 point to get a 3. 27 point is based on those three questions. So should you understand all those FRQ? Yeah, put a lot of emphasis on those FRQ. It really give a huge return about things because everything is kind of related to each other. They're not scattering everything like multiple choice, even though we're gonna practice a lot of multiple choice later. But you want to get as many points as possible because I don't want you just earn a 3 because most of the time in UCF they don't give you credit unless you earn a 4. And if you're engineering, they don't give you credit until they got a 5. So UCF is actually stricter than UF in this perspective. If you're engineering, then you have to get a 5. Otherwise, they will ask you to retake the course again. So you do not put yourself in a position. Take it once, done. Okay? Also, some of you guys should sign up for BC Calc. Come on, Robert. No. You did not do that. Robert, you did not do that. I'll fail you before that happens.
Well, if I think we're gonna do math, I count with like 6. Let's look at 6 on my GPA. Get an 8. All go.
That's so weak. All right. So all right. So we're gonna talk about this question. This question on a certain workday, the rate in tons per hour at which unprocessed gravel arrives at a gravel process plant is modeling by G of t equal to 90 plus 45 cosine t squared over 18. I don't know how they come up with that equation, but that's actually interesting. It's an oscillation between 45s, but it's 18, so between 0 to 8. That's interesting. Okay, so at the beginning of the workday, t equal to 0, the plant has a 500 tons of processed gravel. During the hour of operation between 0 to 8, the plant process gravel at a constant rate of 100 tons per hour. So let's go into annotate this. This type of question you kind of have to read through and reread again. So you're going to spend most of the time doing reading. The calculation is actually super simple. You don't have to do things. You're going to spend most of the time. So this is a 15 minutes question. I will read it for like 3 minutes to 5 minutes minimum. The calculation is going to be only 3 minutes to 5 minutes long. So you should have 5 minutes. So you should spend more time on reading and understanding questions. So what I'm going to do is I'm going to go annotate certain things. So which thing I want to annotate? Which equation? Okay, let's do that. And this is arrival. So not only the equation, it's also arrival. So that means things coming in, right? I don't know if you've ever seen gravel before, but I don't know what's okay. But yeah, they just truckloads come in, right? And so of course they're not gonna come in 10 truckload at once. It's just gonna be like periodically, like one truckload coming and one truckload coming. Now, what other thing I will annotate here? What is that called? Initial condition. So we're gonna different color. Shh. This is gonna be different color. That's initial condition. And anything else that I think is important? Ooh, what's constant rate? Constant rate means, in this case, 100. What's that 100 means?
It's 100 is GFT.
It's GFT?
Yeah.
Is it linear? I don't know. It is linear, but it's not like a linear like this.
No, like
Yeah, it's like that. Okay, so we're gonna say that there is another information that processes gravel at a constant speed of 100 feet per hour, and also the domain is important. So domain is gonna be right here, and one of the most important thing is actually right here. The rate. What is the rate? And circle this tons per hour. So circle this tons per hour. So this tons per hour right here, that's kind of important. So those are the things I'll annotate. All other things useless. So you don't need to read anything that's not important. I don't care about this. I don't care about this. Sorry, I don't care about this. This is not important. So that's just, there's a lot of keywords that's not important. Doesn't matter. So now what happened? I'm gonna teach you how to look at this question same as motion. So for me, like I always think about rate, right? Though this is how I look at the rate. Rate is, in this case, is the velocity, how fast the gravel come into play. So it's really similar to, this is similar notation to velocity. And kind of makes sense. If you're driving 50 miles per hour, and if you drive for 5 hours, that means you integrate 50 between 0 to 5. You're going to get 50t, and you're going to plug in 5, subtract 0, which is 250 miles. So if you integrate the velocity, right? If you integrate the velocity, you get the amount of the distance change. But if you integrate the rate in this situation, what you get? Amount of gravel. Thank you. Amount of gravel that is go into the process plant. Now, in this question, I call it net rate. Why do I call it net rate? Net rate, something is net. That means there is something goes in and there's something goes out. So net rate is equal to in rate, right? In rate. So hold on, let me change this here. Equal to in rate, sorry, minus the out rate. So net rate is equal to in rate minus out rate. So that's the net. Okay. So also pay attention to initial condition. So also pay attention to units. Okay. So let's read this question. So they say G prime of phi. Can you guys use a calculator and find out what G prime of phi? Practice in your calculator skill. And just say, what is G prime of phi here?
and then do we add?
You think, what does that mean? And then before you decide. Yeah, but you can use calculator to do it. Yeah, but that's, nah.
I have a question. When you're doing the operations on a calculator, do you write all the stuff that you're doing on the paper?
Yeah, you do. We've been talking about what kind of stuff you have to write. So I've been writing on the board, but you're not paying attention most of the time.
No, I meant like write the calculations.
You don't have to write a calculation. I hear you just write down G prime of phi is equal to something, but you cannot just say 123. That doesn't mean anything. You have to say G prime of phi is equal to 123 because they expect that you know how to use calculator. But they just, you have to have some type of notation come with it. That's what they want. So what you guys get?
Still writing the problem. What, where?
I don't think it's right either.
Okay,
Yeah, so you gotta take the derivative of it and then plug it in.
oh, I see. I have to zoom out like
Pretty much minus 45.
What? Am I going home?
She's asking me days ago.
Oh, okay.
Yeah, what?
All right, what you guys got?
Still writing.
Negative what?
24.59.
Thank you. Negative 24 point what? 590?
Well, 588.
588. So then just write down 588 because you're gonna have 3 decimal places, and that's equal to g prime of 5. Now, however, that's still wrong. Pay attention to the question. What the question really wrong?
Are we adding 100 or are we?
Tons per hour.
Is it?
No, but like it's
Wait.
already in tons per hour, but the prime of that would be
Change.
acceleration.
No, you're right. You're right. You're going somewhere with that.
Oh, it's awesome. So it's
Well, yeah, we're doing. Hold on.
So what would be the unit here? Remember, g of t is already tons per hour. What's g prime of t?
Hold on.
Think about velocity. It's meter per second. What's the acceleration? Meter per second squared because it's divided by time again.
Oh, it would be tons per hour squared.
Tons per hour square. So you have to write it like that to get all the points. You cannot get tons per hour. You cannot just write down 24.588 negative. You have to write down 24.588 tons per hour square.
So on my calculator, like when I did the table, it only gave me 2 decimal places. So I put negative 24.5.
You can do it outside the calculator. You can do it outside the calculator.
Also, if you go onto like the number like this, it gives you the whole breakdown there.
Yeah.
Why do you think G would have negative? G prime of 5 negative. Why do you think that square root of 8?
That's the calculator. Give it to me. I didn't make that.
Oh, like the letter.
Oh no, I'm not. That's not what I want to do.
Oh, okay.
Okay, so what is this implying? This means implying the rate the gravel is coming to process plant decreasing. Why is decreasing? Because it's negative, right? Decreasing at 24.588 ton hour per hour. So it's hour square. You can do that. So you have to write down decreasing. That's the keyword. Decreasing. Because it's the rate of the rate. Because if your derivative is to find out increasing or decreasing. How do I do the second part? B. Find the total amount of unprocessed gravel that arrived at the plant during the hour of operation of workday. What? You do the integral because the integral is going to give you amount. Does that make sense? Between where to where? 0 to 8 of what function? G of t dt. Because this is a rate. If I integrate of this rate, I'm going to get amount of the gravel. So then you should need to know how to press in the calculator. Man, I can never finish this question. But I'm just gonna finish. I'm just gonna continue to finish. Does that? How many you got?
8.5.5.
8 what?
825. 8.551.
825.551. I'm gonna continue to make this video, and you will have homework about similar questions, and you just have to watch the whole video. And that's gonna be ton, right? Ton.
Wait, you had to add the.
You don't have to add the initial condition because that doesn't make sense. So it's the amount the process plant increasing or decreasing at t equal to 5. Show the work that lead to that. The rate gravel is coming the process plant at a decreasing to 24.588 tons per hour. Okay, so C is asking, is the amount of process plant increasing, decreasing at 5 hour? So what are you gonna do? You're gonna do G. You're gonna do G of 5. Why you wanna do G of 5? G of 5 is gonna be the rate at 5 hour. So what you're gonna get here is gonna be 98.140764. Okay? Now you have to compare this to 100. Why you compare this to 100? This one is less than 100. 100 is going out. 98 is coming in. So 98 is coming in, 100 is going out. Is the thing is decreasing or increasing? So that's the one you have to ask yourself. So since it's less than 100, then therefore it's decreasing. Because this one's less than 100. 100 is going out. But going in is 98. So there was more out than in. So the plant has less material as the time goes, around 5.
So at the interval, like the position or like the
The
value,
rate
like,
at 5.
like the value equation, like where it goes in the tons, it's like 100 or something like that.
Yeah, because this one is 100. This one is whatever goes out at 100 per hour. But when it comes in at 98 per hour, guess what? Your plant has product is going decreasing because there is a net flow of in is less than out. Out is more, so that you have less material as the time goes at that moment.
So how do you find the amount?
We're gonna talk about the next one, which is the amount. So what is the maximum amount of process plant during the hour operation in this workday?
For the mean, how do you find the amount to compare it to?
You didn't find the amount, you just find the rate. So you plug in 5 into G of t. You find the rate of G of t is the rate of the speed is going. Now, since it's less than 100, then you have to think about what is that.
So where does the 100 come from?
100 is coming from, this says the plant is processed gravel at a constant rate of 100 tons per hour.
It says that in the question?
You say that in the blue part. So that's the out rate. Yes, Daniela?
Use both calculators, or can I only use one?
You can use as many calculators as you want. It doesn't really like, but learn to use one, then that's probably easier.
I'll learn to use one.
Yeah,
Right
so-
now, I'm better at this one, and with the test so close, I don't want to like.
Okay, that's fine. If it's something doesn't work, then you can use the other one. It's for your backup plan. Okay,
Also, for A, I got on this calculator, it only gave me 3 decimal points. So
it should give you 3 decimal point if I do it outside screen.
It gave me 3 or Mark one. It's like giving me 3, but then like for y1, but then for the derivative, it's giving me 2.
Yeah, so give me a second. Let me finish the last part. Okay, so the last one is what is the maximum amount of process plan during the hour operations. So you have to take account into how much is the amount. So I'm going to write down amount equation. This amount equation is A of t. Is equal to, well, depends on how much things you have in the plant. It's going to be 500, right? 500. And plus integral. Well, we're going to talk about different times. We're going to talk about between 0 to t of g of t minus 100 dt. Well, why do I do that? Because 500 is what you have in the plant. Now, the integral is going to says, you know, how much the difference, how much the displacement. But I hear you got in minus out. In is constantly changing. Out is a constant. So it's going to be minus 100. So then you have to think about that. Then you have to go ahead and graph the g of t minus 100. So you also have to graph g of t minus 100. So g of t minus 100, you're going to graph this. So when I graph this, I'm going to show you g of t. Guys, be quiet. Shh. Okay, so I'm going to set it equal to 0. So I'm going to graph this and finding the x-intercept. Why? If I find the x-intercept, I know that's a critical number. In this case, if I graph this function right here, I'm just going to graph it on the calculator with TI-84 or TI-Nspire. Okay, so TI-84 or TI-Nspire, you're looking for the zeros. When you're looking for the zero, guess what? You're going to find the time as a critical value. That critical value either is going to give you maximum or minimum. So in this case, that critical value is going to be it's going to be a maximum. So remember, we have to do a table, right? When they ask the maximum amount, we're going to have to do t. At 0, it's going to give you 500. There's A of t. But at 4.92348, it's going to give you 635.376. At 8, it's going to give you 525.551. So maximum occur right here. Maximum occur right here. So what is the amount? 635.376. And this is the justification. This is justification. Okay, this is the justification. Okay, so this is what you're looking for, and that's how you're gonna get it. Remember, is net rate is the amount of in minus out. This is the net in minus out. Okay, in minus out. Now this is gonna find a critical point. Okay, so I will post this video on the YouTube, as well as the other two videos for TI-Nspire and TI-84CE. Okay, so now this video I don't have a cool thumbnail, but the other two I do. So it's very ugly. It's so ugly.